Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle, and it's called Dutch Flatmates Bulbous Arrows by Flinty and Palpot. And take the easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. We also have Dutch flats, or Dutch flatmates, where every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So if you have a 5 anywhere on this grid, it must have a 9 below it or a 1 above it. That's all you need to know. It could have both, but it doesn't need both. We also have bulbous arrows, where the sum of the digits in the bulb equals the sum of the digits on the attached arrow. Okay, this is interesting. I've never seen this variant before. So interesting. It's essentially the same. It's basically the same as like what do you call it? An equal sum line. Yeah, this is basically the same as an equal sum line. It's just that there's only one splitter, right? And the regions are essentially these 3 digits, and in this example, it would be these 3 digits and these 8 cells. So you sum up these 8 cells, and they must be equal to the sum of the digits in the bulb. So you could actually draw a line like, for example, something like this. And you have the, I don't know. I can't mark that, unfortunately. But basically you have the marker there. Or I guess you could, this one's a little more difficult. It doesn't really follow a line. But you could do something like here, and then this is the separator. And then it's the equal sum line, right? That's essentially what this is. So as an example, you could have something like, say, I don't know, 5 and 8, and then this is like 3, 1, and 9. So the sum of the arrows, which is 13, must equal the sum of the digits in the bulb, which is 5 and 8, which it does. So that works as a valid example. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So we know these 5 digits must equal the same as these 2 digits. Well, the minimum of 5 digits is 1 plus 2 plus 3 plus 4 plus 5, which is 15. The maximum of 2 digits is 8 plus 9, which is 17. Oh, actually, it could be 9 here. So this could be 9 and 9. I guess one thing where it's different, this is different from equal sum lines, is normally equal sum lines cannot have a repeat. But you could always change that rule. So this could be 9 plus 9. So this is at least 8, at most 18 here. This is still at least 15. So it has to be 6 through 9 here, and 6 through 9 here. And these are 1 through 8, but I don't want to mark those right now. Okay. These 2 digits add up to that one, and these 2 digits add up to that one. So this is like a reverse arrow here. That's interesting. These 2 digits add up to that one. Again, this could be like a reverse arrow. So you could have the bulb here, or the circle here, and then you have 2 arrows here. And these 2 digits sum up to what these 3 digits are. These 4 sum up to what these 2 are. These 3 sum up to what these 8 are. Okay, so these 6 are unique. So that's at minimum 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. This is at minimum 3, and therefore that's 21 plus 3 is 24. But the maximum you can have of 3 unique digits is 7, 8, and 9, which adds up to 24. So they must add up to each other. Since the minimum of one adds up to the maximum of the other, those must be, you have to set those equal to each other. Therefore, this is 7, 8, 9. This is 1 and 2, and these are 1 through 6. Oh, that's interesting. So this cannot be 1 or 2. In these lobes, it has to be 3 through 8 because you cannot have more than 8 in in a 5-digit cell adding up to 18, or 5-cell cage, which is essentially what this is, adding up to 18. What else do we have? The rest of box 1 is the digits 3 through 6. Mm. mm. These are equal again. These are equal to this. This is essentially the reverse arrow. It's kind of weird that they have it this way because you could just have a bulb here and then an arrow pointing down here, and then a bulb here and then an arrow pointing up here. But I don't know. They do it that way. It's kind of strange. Which means this is equal to this. These two are equal to that, which means these are even, right? Because these are the same, these are the same. So it's 2 times some number, which means all of these are odd. Well, that doesn't really tell us much, but there's no restriction on bulbs. So I guess there is that. This could actually, these 2 digits could actually be the same, and these 2 digits could be the same. Well, it's the same as arrow, I guess. Huh. These 4 digits add up to at least 10. That's fine. This is at most 9 plus 8 times 2, which is 34, but that's a lot. So that could still be a lot. Hmm. So the thing is, this could actually be 1, 2, 3, 4, 8. And then this is 5 and 6. That's certainly possible. Uh, hmm. These cannot add up. These cannot have a 9 in them because they add up to another digit. Uh, what else can you have here? Hmm. Um. Hmm. 9 can be here, here, or here. one thing this cannot be is it cannot be 15. Right? Then that would require these digits to be 1, 2, 3, 4, 5, which means this would have to be 6 and 6, which means a repetition in the same box or row. So this cannot be 6. I think one of these has to be a 9 at least. Sam, you can't have 1, 2, 3, 4, 6 in this box. Because the problem is you would have 5 and 5 there. So this can't be 16 either. This is at least 17. And it could be 18. If you have, okay, so if you have 17, it's 1, 2, 3, 4, 7, or 1, 2, 3, 5, 6. If you have 18, you could have 1, 2, 3, 4, 8, 1, 2, 3, 5, 7, or 1, 2, 4, 5, 6. So either way, 1 and 2 is in the bulbous arrow, the bulb part of the arrow, which means this cannot be 1 or 2. This cannot be 1 or 2. So again, 1, 2, 3, 4, 7 leaves this as 5, 6. Which would mean 1, 2, 3, 4, 7. So this would be 8, 9, 8, 9 if that were the case. 1, 2, 3, 5, 6 actually doesn't work. So it's 1, 2, 3, 4, 7, adding up to 17. And or it would have to be 1, 2, 3, 4, 8 for 18, which makes this 5, 6, 5, 6. So then this would be 7, 7. It cannot be 1, 2, 4, 5, 6, because then this would leave this as 3 and 3. So 1, 2, okay, so we have 1, 2, 3, 4, 8. Sorry, 1, 2, 3, 4, 7. 1, 2, 3, 5, 6 does not work. So 1, 2, 3, 4, 7, 1, 2, 3, 4, 8. Which leaves 5, 6, 5, 6. 1, 2, 3, 5, 7, which leaves 4 and 6. And 1, 2, 4, 5, 6 does not work. Okay, so if it's 1, 2, 3, 4, 7, that leaves 5, 6, and 5, 6. If it's 1, 2, 3, 4, 8, that also leaves 5, 6, and 5, 6. If it's 1, 2, 3, 5, 7, that leaves 4, 6, and 4, 6. So 6 has to be ones of the ones outside the bulbous area. And it cannot be here because one of these two must be a 6. Either way, 2 out of 7, 8, or 9 are here. So you have, again, 1, 2, 3, 4, 7, adding up to 17. 1, 2, 3, 4, 8, adding up to 18. Or 1, 2, 3, 5, 7, adding up to 18. 1, 2, 4, 5, 6 does not work. Okay. Can this ever be 7? I don't think so, right? If this were 7, that means you have to have 1, 2, 3, 4, 8 somewhere in this set. Or 1, yes, it would have to be 1, 2, 3, 4, 8. And therefore, this would be 9 plus 9. But since neither of these can be 9, this would have to be the 9. So this can never be 7 here. This is 8 or 9. Hmm, interesting. Um, what else do we have? Oh, since this is the sum, wait, no, it's part of. Never mind. These two are the sum up to this, right? I was gonna say since it's the sum of another one, but it's not. It's in fact the reverse. Um, what this cannot be is 1 here, but that doesn't really tell us much because if this is 6 and 1, that adds up to 7, so this would have to be 1, 2, and 4. Even if it's 5 and 1, this is 1, 2, and 3. 6 and 2 does work, though, because this could be 1, 3, 4 here. Huh. These 4 digits add up to at most 17. What's the smallest number this could be is kind of the question, right? Even if this is 10, this has to be a 5 at minimum. Can it ever be smaller? Can it be a 1? This would then be 2, 3, 4 at 2, 3, 4, 5 at minimum, so no. If this is 2, this would be 1, 3, 4, 5 minimum, which adds up to 13, but 2 doesn't add up with another digit to add up to 13. 3 means 1, 2, 4, 5, and it could be 9 here. So therefore, this is at minimum 3 here. That doesn't really tell us much. Oh, we have the flatmates, right? Well, 5 cannot be here. 5 can't be here. 5 can't be here. 5 can't be on the outsides. There we go. That's where it is. I always forget the Dutch flatmate stuff. 5 cannot be on the outsides because 1 is not above it because of the 1-2 pair. 9 cannot be below it because 9 can't be in the bulbous era. So therefore, this must be 4 and 6, which forces this to be 1, 2, 3, 5, 7. If it's 1, 2, 3, 5, 7, that means these add up to 18. So this has to be a 9. This must be a 9, which means this can't be 9. The 9 has to be here because there's no other place for it in the box. It's 1, 2, 3, 5, 7, which makes this an 8. This can't be 8. This can't be 4. Can't be 8. The 5 has to have a 1 above it, which neither of these can have. This can't have it. Or a 9 below it. Well, the only place where the 9 can be below it is this cell. So this is a 5. This can't be 4. This can't be 4. Therefore, this becomes 1 or 2. This is 1 or 2. These can't be 5, which makes the 5 in box 1 be there. And the remaining of these digits are 4, 6, and 8 here, which means 4 cannot be here. So this 5 has a 9 below it. This 5 must have a 9 below it, so this is a 9. So that's satisfied. This is satisfied. This 5 cannot have a 1 above it, so it must have a 9 below it, so this must be a 5, which means this 5 is satisfied, so this cannot be 5 here. This is, one of these is 3. We have a 1, 2, and a 7 as a possibility. Let's see. Excuse me. So 9 cannot be any of these cells, and it can't be here. This cannot be 9 because these two digits add up to another digit, and 9 plus another digit adds up to 10 at least. Same with this. So where's the 9? It has to be here. And this cannot be 1, 8. It could be 2, 7, 3, 6, or 4, 5. This is 7 at most, which means this is 1 through 6. This has to be at least 3, 4, 5, 6, or 7. 8 has to be one of these digits here. This is 9, so that means this adds up to at most 15. 7 and 8. That seems okay. 5 cannot be here because it doesn't have a 1 above it or 9 below it. And this can't be 5, same, because it doesn't have a 1 above it or a 9 below it. So this cannot be 4, 5. It's 2, 3, 6, or 7. This 5 could have a 1 above it. If this is a 5, it could have a 1 above it. And that would add up to 6. Or it has a 9 below it there. The 5 in column 5 has to have a 1 above it no matter what. So 5 can be any of these 3 digits, and 1 has to be one of those 3 digits there. Since once is one of those digits, this cannot be a 1, which makes that a 2. This cannot be 2 or 7. This must be 3 or 6, which eliminates 3, 6 from the rest of the column and the rest of this box. So this can't be 3 or 6. This can't be 3 or 6. What can this be? This cannot be 4 anymore because that would have to require those two to be 1, 3. This can no longer be 5 because it requires a 1 above it, which would make that a 6 then. But that's not allowed. If this is 5, this has to be 1, 4. If it's 7, it has to be 2, 5. So if that's the case, this can't be 2 there. This 2 means this can't be 2, so this is a 1. Which means we don't have a 1, so it cannot add up to 5. It must add up to 7. So this must be 2 and 5. Wait, that doesn't work. Oh, right. The 5 still could be here. Okay, and in fact, it has to be. Because the 1 can't be above it. So therefore, this is 2. And this is 5. Which makes this 1, 4, 8. 5 can no longer be here, so this can't be 1. 1 has to be above it, remember? This is a 1, 4, 8 triplet, which eliminates 1, 4, and 8 from the rest of the column. So this can't be 4. This is 6, which makes that a 4. Remaining digits are 2, 3, and 7 here. Remaining digits here are 1, 4, and 5. But this cannot be 1, and this can't be 5. And the remaining digits in column 5 are 3, 7, 6, 8. Okay. So this 5 has a 9 below it, so that's satisfied. We don't know if this 5, where this 5 is that has a 1 above it. So far this is at least 9, which makes that at least 10. So that means this is at least 10, which means a 1 cannot be here because a 9 cannot be along in this bulb. So it's at least 2. 2 through 8. Nine cannot be here. 9 cannot be here. Can 9 actually ever be here? Maybe? If it's 9, it could be with 1, 2, and 3, and 7, 8. That seems to work okay. We need a 5 in the bottom row. So that means 1 has to be above it. Well, 5 cannot be here, so 5 can be either here or here, which means there has to have a 1 above it, which means this cannot be 1. Where else can the 5 be? These can no longer be 2, and these can no longer be 1. So 5, well, technically it could be here. But that would require a 9 below it. So you'd have at minimum 5 and 9. So 5 could not be here. 5 could be here if a 9's below it, or 5 could be any of these spots with a 9 below it, or a 1 above it. So 5 cannot be here specifically. But that doesn't really tell us much. Oh, okay. Again, 5. Well, no, never mind. No, so 1 has to be one of these 4, but it could be here too. Can this ever be 5 and 1? Maybe. Then you could have 1, 2, 3 here, right? But then that would be 3. This would be 2 and 1. That seems okay. Possible. I'm not that good at Dutch flatmates, I will say. Hmm. Hmm. Where are the 5 possibles? The 5 could also be here, which means the 9 could be below it. That's interesting. If this is not 5, what does that mean? That means one of these is a 5. So it's at most 13. That would mean 1 is above it, so 1 could not be here. At most 13, you'd have to have at least 2. You'd have to have at least 2, 3, 4, and 5 here, which adds up to 14. So 5 cannot be either of these cells. right? Because you need a 5 here, but this is at minimum. This would then be at minimum. 1 would be above the 5. You'd have to have a 2 here then at minimum, which 2, 3, 4, and 5 adds up to 14. And 5 and 8 at most adds up to 13. So 5 cannot be in either of those cells, which means 5 has to be one of these two. So 5 has to also be one of these two, which means it needs a 9 below it or a 1 above it. Again, if this is 5, 1, this is 2, this is 3, 1, 2. That seems reasonable. If this is 5, 1, so 1 in box 7 and 1 in box 1 have to be in columns 2 and 3, which eliminates 1 from the rest of the cells in that column. Therefore, 1 must be in column 4, or column 1 for box 4. Okay. The 5 in box 4 cannot have a 1 above it because one of the ones, again, because there cannot be any at ones except for in rows 1 and 8 for columns 2 and 3. So 5 could be any of the 6, but 9 has to be following it, essentially. It has to be below it. This 5 could have a 1 above it or a 9 below it. Actually, where is the 5 in row 4? It cannot have a 1 above it, so therefore it must have a 9 below it. So wherever the 5 is must be one of the possibilities for 9. So 5 can be any of these, which would make 9 one of those two. This cannot be 5 and 9 because, again, this is at minimum 1 plus 2 plus 5 plus 9, which is 18. Sorry, 17. But then that would require this to be 8 and 9, but this 9 would preclude that. So this cannot be 5 and 9. This could be 5 and 9. This could be 5 and 9, and this could be 5 and 9. We know there's no other 9 in the rest of row 5, though, because one of those 3 has to be a 9. In, again, box 4, you could have a 5 here with a 9. This is at minimum 5 plus 3 plus 4. So technically it has to be at least 13, with that being 1. Can this ever be 8 is kind of the question. 8 plus 3 plus 5 plus 1. So 5, 3 is 8, plus 8 is 16, and 2 digits can never add up to 16. So this cannot be 8, this is 4, which means this can't be 4. Can it be 4, 6, and 5? No, because that adds up to 15 without the 1. And therefore it would be at least 16, and 7 and 8 can only add up to 15 at most. So this is a 3, which makes that a 6. This can't be 6. Can this is at least 12, so this must add up to at least 13. 4 is out, so this has to be 7 and 8. So we have a 7, 8 pair in column 9, which eliminates 7 and 8 in the rest of the column. This can't be 8. This must be 1, which makes that an 8. 15 plus 12 must be, or sorry, 15 minus 12 is 3. So therefore this is 3. The remaining digits here are 2, 5, and 4. But this cannot be 5 because of the 5 in column 1. One of these is a 1. If this is a 5, it needs a 9 below it. Which would mean this is at most 13 if this is a 5, but that's possible. Hmm. 9 has to be one of these 4, but it could be any of them. 3 has to be one of these. 5, again, has to be one of those 2. If this is 5, 1, that forces this to be 1, 2, 3 to add up to 6. So therefore, this... If this is 5, 1, this has to be 4, this has to be 2. If this is not 5, 1 here, that means this has to be 5, 1. So this can never be 4 here. One of these is 1. We also have 7 and 8 have to be here, right? Because there's no other place for the 7 and 8. That's actually very interesting, and that was a byproduct of the Dutch flatmates. So this has to be 3, 6, and 9 here. Obviously this can't be 9 because it would sum up to something that's less than 9. These digits have to be 1, 4, and 5. But this can't be 5. And these have to be 2, 6, and 9. But that can't be 9. One of these is 5, and it could have a 9 below it. Can this ever be 1? 1 and 9 with 1, 2, 3, 4? Maybe. Where is a 7 in column 7? Can't be any of these 3, can't be any of these 3, so it must be one of these 3. This can never add up to 3, because you would have to have at minimum 3 here and 1. Actually, this can't even be 1. This is at least 2. So if this is 3, it could be 3 here, or 6. If this is 6, this has to be 3 here, which makes that 9. So it could be 3 and 3. Adding to 6, and therefore this is 9. It could be 3 and 6, and that... Okay, this cannot be 3 and 6, then adding up to 9. Because that digit would then eliminate the other digit here. Similarly, it can't be 6 and 3 adding up to 9 because, again, this would have to be 3. So this has to be 3 and 3. So this is 3 and 3, which means this is 6 and this is 9. So 5 cannot be here because otherwise a 9 would have to be below it. So in this box 4, where can the 5 be? 5 can't be here. 5 cannot be here because 9 can no longer be below it. 5 could be here with a 9 below it. 5 cannot be here because 1 can't be above it. 5 can't be here because 1 can't be above it. 5 can't be here because 1 can't be above it. And in all those cases, 9 is not below it. So this must be 5 and 9. Which means this matches. Which means this can't be 5. This must be 2. This must be a 5 here, which means there has to be a 1 above it. So this adds up to 6, which makes this 1 and 2 here. Which means this can't be 1. This can't be 2. This is 4. This can't be 3 or 4, so this is 6, which means none of these can be 6. This 1 means this can't be 1, so that's a 2, which makes that a 1. This 3 eliminates that 3, so that's a 4, which makes that 3. This can't be 1. The last remaining digit in column 3 is a 4. So this is 4, which makes that a 5, which makes that a 1, because a 5 has to have a 1 above it. And this makes this 4. Okay, how many 5s do we have? So we need one more 5 here. It could have a 9 below it or 1 above it. So the 5 has to be one of these two. This can't be 3, 4, or 5 here. This can't be 3. This adds up to at least 12. So it has to be 6, 7, or 8. Well, it had to be 6, 7, or 8 anyways. This is 7 or 8. So say it was 6, 5, and 4. This can never add up to 15, so that doesn't work. So this must be a 3, and this must be a 6. Which means that can't be 6. The remaining digits in row 4 are 1, 2, 7, and 8, but 7 cannot be either of these. This 1 means this cannot be 1, so this is a 2, which makes that a 1. This can no longer be 2 or 3, so this must be 7, which makes that a 2. This can't be 3 or 7. This can't be 7. This 7 means this can't be 7, so this is 3, which makes that a 7. This can no longer be 7 here. This 7 means this is an 8, which makes that 7. This 8 makes that a 6, which makes that 8. This cannot be 7. So where is the 7 here? It has to be here. This can't be 7 or 8. It's 6 and 9. This is 6 or 9. The remaining digits in row 5 are 3, 4, and 5, but this can't be 5. You have to have a 1 above, or actually you could have a 9 below it. You still could add, okay, you cannot add up to 10 anymore. You could add up to 11 if it's 1, 2, 3, 5. This could be 6 and 5 here. So this can never be 1 anymore here, right? Because if this is 1, that would have to, 1 cannot be above these. So the 5 has to have a 9 below. Well, So you have 5 and 6, that's possible. With this being, so this would have to be 5, 1. Okay, in that case specifically, it has to be 5, 1 here, because this is 5 and 6. The 9 would have to be here, which works. This would be 2 and 3, so this would be 2 and 3 there. What about 4 and 9, or 5 and 9? 4 and 9 adds up to 13? You can't have 8 with 13, right? Oh, and you have to have a 5. So 13 minus 5 would mean 1, 3, and 4, but that's not possible in these cells. So 4 and 9 doesn't work. What about 5 and 9? That's 14 minus 5, because one of these has to be 5. And that doesn't work, right? 14 minus 5 is 9. So you have 3 digits adding up to 9, but one of them has to be a 1. Cannot be 1, 3, 5. It can't be 1, 2, 6, and 2, 3, 4 doesn't, this does not include the 1. So this has to be specifically 1, 2, 5, and 3, which makes this 5 and 6, which makes that a 9 because it has to have a 9 below this 5. So that's satisfied. These are all satisfied. All the 5s I think are done, right? Or this 5 has a 9 below it, this 5 has a 9, this 5 has a 9, this 5 has a 9, 5 has a 1 above it, 5 has a 1 above it, 5 has a 1 and a 9 below it. 5 has a 9 below it, 5 has a 9 below it. Yep. So this cannot be 5, this cannot be 9. This 2 means this can't be 2, so this is 7, which makes that a 2. This 1 means that can't be 1, so that's 3, which makes that a 1. This can't be 7 because of that 7, so this is 8, which makes that 7. This 2 means this can't be 2, so this is 6, which makes that 2. This has to be 4, this has to be 8. This 1 eliminates that 1, so that's a 4, which makes that a 1. We have a 6 here because of the 4, 8 in the column. That leaves 8 here and 4 here. This can't be 7 because of that 7, so this is 8, which makes that 7, which makes that 8. Therefore, this is a 7. Sorry it took that long. I'm just not, well, I'm a little tired, I will say. And also, I'm just not that adept at identifying where Dutch flatmates can be. It's definitely not one of my stronger rule sets. It's not as bad for me as Knight's Move, but I'm not that great with Dutch flatmates, though, I will say. Anyways, I hope despite that you enjoyed this episode, this solve, and I'll see you next time on Frank Puzzles. Take care.